Welcome to today's video, where we will delve into a programming problem that you may encounter. The issue at hand revolves around a piece of code that involves functions that may or may not throw exceptions. We will explore why different compilers handle exception handling in distinct ways, specifically in the context of the noexcept specifier. So, let's jump right into this interesting problem. In seeking a solution to the aforementioned problem, it's crucial to understand that the presence or absence of exception handling depends on whether the functions involved are throwing exceptions. If the compiler can ascertain if an exception might be thrown, then handling for noexcept to call std terminate is essential. In the code provided, the use of std vector and v static underscore casted size underscore ti in the zoo function involves memory allocation and deallocation, potentially invoking user replaceable functions that could throw exceptions. However, since the vector is immediately destroyed in zoo, the compiler may optimize away memory allocation, thereby eliding the need for exception handling in certain scenarios. In summary, the differing approaches taken by compilers like GCC and Clang in generating exception handling code highlight the nuanced interplay between the noexcept specifier, potential exceptions, and optimization. While compilers may optimize code to eliminate unnecessary operations, adherence to the standard specifications regarding exception handling is paramount. By understanding the intricacies of memory allocation, deallocation, and possible exceptions, developers can navigate such scenarios effectively. And with that, we've covered an interesting problem and its solution in the realm of exception handling and optimization. Thank you for watching, and remember to like, subscribe, and drop a comment below with your thoughts or any programming jokes you have in mind.